Hi to everyone. In this lecture, I am going to discuss about symbol table. What is meant by symbol table? This term itself reveals it's a table. Table that you know very well, it's a collection of cells. The intersection of the row and column which will be called as a cell in which the data will be entered. Is there any guesses? Since we are seeing here as a symbol table, do you mean this is a table in which we are going to have a symbols? What are all these symbols? You may say a dollar and then a comma. So many things you will say it as in symbols. But here the symbol table actually used to store the tokens. Actually, it is used to store the informations about the various entities such as objects, classes, variable names, interface and function name. Actually, the symbol table is used in a compiler. Okay. Compiler that you know very well. We are just going to make use of the compiler to compile our program. Compilation means you are going to convert your source code into the object code. So during that process, we are just going to make use of the symbol table. Symbol table is used by the analysis and the synthesis phase. Okay. Let's see how the symbol table can be implemented in the compiler. At first, I am just going to write one small module. For example, I am writing here this int main. So within this one, I am going to define one function. Okay. So for the function, I am writing the return type as int add. So within this function, I am going to have the two variables as int a comma b. Okay, and I am going to have one more function as int sub. So within this function, I am going to have int c and d. Okay. So now I am just going to create the symbol table for this one. As I said earlier, symbol table is used to store several entities like variables name, interface name, functions names and so on. No. So first this is one block, outer block, and this is one procedure. This is also one procedure which is present within the main function. Okay. So what I am just going to do it here is I am just going to create one symbol table here, and I am going to write it here as yes, I am going to write the symbol here, and I am going to write the type here. Okay, so see here, it's a main. Actually this symbol table is for main block. Okay, so here what are all the two things available? I am not having any variables and so on, but I am having the procedure. So I am writing here is add, and one more is sub, and writing here is function. Actually it's not a procedure, it's a function. So I am writing here is function. Next, this main is having two subblocks. One is the add and next one is the sub. So I am just going to write one table. So here I am writing symbol, and I am going to write the type here. This block is for add. Okay. So here what I am going to write it here, I am going to write it here as A and B. Of the type, it's of the data type int, and it's nothing but a variable. And b is also an integer variable. So here you can write int variable. Next, for sub, we have to add one more table. So here symbol, and you can write type here. So C and D, it's of integer variable. It's also integer variable. So this block is for sub. So what I am just writing it here is, I am just going to implement this source code in terms of the symbol table just for easily parsing my source code. So this structure is called as a symbol table. This block is for main, and this one is for add, and this one is for sub. You just see here, from the main I have taken one line and then I have written one table here. So what it means is, this table, that means the procedure, the function add is present within the function main. Okay, and in the same way, sub is one of the function which is present within the main. Okay, now we can redraw the structure like this one. You can consider this as main, and this as add, this as sub. Now see, the structure is, this structure is typically looking like binary tree, right? In binary tree you will consider this as root, and this is L child, that means left child, and this one is right child. Alright, so what can I say here is, I am just going to make use of this structure in terms of BST. BST means binary search tree. It's a difference between binary tree and binary search tree. Means, if it is a binary tree, just for an example I am saying, if I am having 10 here, and I may have 12 here, and I may have 8 here, there won't be any problem in binary tree. But if it is of a binary search tree, means the left child data must always be less than the root node. In such a case, 8 must be written here, because 8 is the data which is less than the data present in the root node. And right child, what's the right child? Here you can write 12, because 12 is greater than the root node. Once if you are taking the binary tree will have the maximum of 2 child for every node. But there is no conditions for the data which is present on the left child and the right child of the root node. It can be of any node. It can be of a root node, X, or else internal node, whatever it may be. There won't be any conditions just like a binary search tree. But if it is of a binary search tree, F child which will always be less than the root node. Right child must be always greater than the root node. Okay. So why we are going for the binary search tree means, in order to search for a particular item easily, we can make use of the binary search tree. What's the relations between binary search tree and symbol table means? We are just going to implement the concept of symbol table with the help of a binary search tree, hash tables, and so on. I hope that you got a clear idea about as how to draw the symbol table for your source code. In case if you are having any doubt, kindly post your queries. Thank you.